I am convinced that the canyon networks we can see on Saturn's moon Titan are evidence for a vast global ocean hidden beneath the surface. This may sound far-fetched, but stay tuned, and by the end of this episode, you will see why I think this is a viable hypothesis. So let's start with what we know about these canyons. They were discovered in 2007 by the Cassini orbiter, when it made close passes over Titan. Back then, we could only see a small portion of the moon's surface, and the resolution was not good enough to make out any details. But ever since then, we have been getting more and more data. Today, we know that the canyon-forming structures on Titan can stretch for hundreds of kilometers. They look like gigantic fault lines, or like enormous plates of ice cracked across the moon's surface. In total, there are 4 main structures which are named after famous scientists who studied our solar system. There is the 600-kilometer-long Salyut Vostok structure, the 340-kilometer-long Andrew Ingersoll structure, the 260-kilometer-long Mark Michelli structure, and the 180-kilometer-long John Hopkins structure. And these structures tell us 2 things. First, they show that Titan's outer shell is not frozen solid. If it was, then it would crack if the moon cooled down slowly. But clearly that did not happen, so the outer layer must be mobile, although extremely slowly. Second, these structures hint at some kind of force pushing up from below. A cooling moon should collapse under its own gravity, so clearly something is supporting Titan's surface. Okay, now I can hear you asking, what does this have to do with an ocean? Well, just consider the fact that here on Earth, we also have big structures that spread across the planet and which hint at a molten core. They are called mid-ocean ridges. You see, the Earth's crust is not frozen solid either. It is broken into tectonic plates that move around on top of the mantle. The plates move apart at mid-ocean ridges. Molten rock from the mantle wells up and solidifies into new crust, pushing the plates apart. And that keeps the Earth's surface from collapsing under its own gravity. The same might be happening on Titan. Magma chambers deep inside the moon could keep melting huge parts of its outer shell. We know that Titan has a liquid core. This was already proven in 2015 by the Cassini space probe, which detected how the moon wobbled as it orbited Saturn. The wobble revealed that the core makes up half of the moon's radius, and that it is liquid because otherwise it would not be able to flow and adjust the moon's shape. But how could a liquid core keep Titan's icy shell from collapsing? Well, imagine you have a balloon, and you blow air into it. The air pressure inside pushes against the material of the balloon and keeps it from collapsing. The same could be happening on Titan. The liquid core could exert a high enough pressure to support the weight of the icy shell. And if that is the case, then it might even be possible that the pressure is so high that it melts parts of the outer shell, creating vast magma chambers filled with liquid water. But wait, I thought Titan is a frozen wasteland. How could there be an ocean? Well, it is true that Titan's surface is very cold. Temperatures vary between 90 and 100 degrees Celsius. However, that is because the atmosphere is so thick. It acts like a warm blanket and keeps the surface from cooling off. Without the atmosphere, temperatures on Titan would plummet to -180 degrees Celsius. As soon as we remove the insulating atmosphere, the pressure drops drastically, and at some point, the pressure would be low enough that water cannot remain liquid. Scientists estimate that such a pressure is around 1 bar. On Titan's surface, the atmospheric pressure is around 1.5 bars. So the transition from liquid to solid should take place somewhere between 10 and 15 kilometers below the surface. This means that once you get past the cracked outer shell, you would find a thick layer of ice that gradually turns into liquid water the deeper you go. And eventually you would reach a vast global ocean. Some scientists say that such an ocean could contain up to 50% of all the water in Earth's oceans. That would make Titan the water world of our solar system. Of course, the problem with this idea is that we do not have any direct evidence for it. The detection of the cracked outer shell is indirect. It comes from the analysis of the surface topography. Basically, scientists have looked at pictures of Titan and tried to figure out how tall the different regions are. But we do have some direct evidence that hints at the existence of a liquid ocean. And that is the reason I think that these cracks are evidence for a global ocean. You see, in 2014, Cassini found something very strange on Titan. It discovered that huge parts of the atmosphere escape into space. We are talking about tons of gas escaping every second. It is a big problem for scientists because no one knows what keeps Titan's atmosphere from escaping as well. If there was no atmosphere, then the gas escaping through the cracks would not be a big deal. But given that the atmosphere is hundreds of times denser than the gas escaping through the cracks, scientists were baffled. They were especially confused because hydrogen and nitrogen, the most abundant elements in Titan's atmosphere, do not easily escape into space. It takes incredibly high energies for that to happen. For a long time, scientists assumed that something weird was going on with Titan's atmosphere. Maybe it was much hotter at some point, and most of the gas just cooled down and condensed into rain or snow. Or maybe it was never as thick as it is today, and the current atmosphere is the result of a huge impact event. But recently, scientists came up with another explanation. Maybe there is a huge amount of heat coming from the interior and keeping the atmosphere in place. But if that is the case, then there should also be liquid water on the inside. Just think about it. If there is enough heat coming from the core to keep thousands of kilometers of ice from collapsing, then it is enough to melt water as well. And the funny thing is that we have seen similar processes here on Earth. Volcanic activity on Earth releases tremendous amounts of heat from the interior. It is so much heat that it keeps Earth's entire core molten. In other words, volcanic activity drives the dynamo effect in Earth's core, which creates our magnetic field. On Titan, there are no volcanoes, but there could be vents. Vents are basically holes in the crust through which heat and gases escape. Here on Earth, vents play a crucial role in sustaining ecosystems. Entire ecosystems live off the energy that comes from the vents. Some of them even host life forms that do not use sunlight as energy. Instead, they use chemicals that come from the vents. On Titan, vents could have a similar function. They could host ecosystems that do not rely on sunlight. We already know that Titan has organic molecules in its atmosphere. And while these molecules cannot support life as we know it, they could be the building blocks of other kinds of life. Vents could also explain why Titan's atmosphere has so many holes. Maybe the escaping gases are not coming from the atmosphere, but from the interior. Maybe the atmosphere is not as old as the moon itself, but it was built up by the release of gases from the interior. It would not surprise me if scientists confirm the existence of an ocean on Titan. If they do, I will definitely make another episode about it. By the way, if you want to learn more about our solar system and the discoveries of the Cassini space probe, I recommend that you check out the playlist in the description. All the videos in that playlist were produced by a fellow creator, and they are great. Thanks for watching. See you tomorrow.